My name is Professor Overton. This is Digital Logic. I recognize some of the names on the roll from Intro to ECE. So you pretty much know what to expect from me. But for those of you who have not been in one of my previous classes, I have this little slide presentation. What are we going to be covering in this class? Number systems, basic digital logic gates, Boolean algebra, gate minimization, combinatorial logic, and sequential logic. But those are the 6 main topics that we're going to be covering. Gate minimization, there's a couple of techniques in that. What you need to know. You should take notes. Give more on that in a moment. Ask questions. If you don't ask questions, I don't know if you're getting the material. So, and in general, communicate with me. Already had one student email me this morning about because they're sick, and I can accommodate. Communicate with me. Let me know what's going on. I can work with you. But only if you communicate with me. Let me know in advance when you can, and as soon as possible when you can't. Now, I will allow notes on quizzes and tests. There's a lot of material that gets presented in these in a semester, and I don't expect you to memorize it all. So printed notes are allowed on quizzes and tests. I video record my lectures. Generally, they are available on YouTube the following day. I put the link to those videos in an announcement on Canvas when they're uploaded. I'm currently having some issues with some software, so it might be a little bit delayed before these first few lectures get on YouTube, but they will be getting there eventually. And I will be available outside of class. I am an adjunct professor, which means I'm part-time teaching-wise, but I'm generally here close to 40 hours a week. So I am available outside of class during regular office hours, which will be on the board here shortly, as well as other times outside of those hours. What makes up your grade? Attendance. I'm all about attendance. If you don't show up, you're probably not going to get a good grade. 20% quizzes. There's a little bit of homework, 15% of your grade there. And exams, 30%, and the final exam is 25%. All this will be laid out on the in the syllabus, which I'm having a hard time. They changed the format that we're supposed to use for our syllabus, and I'm trying to work through all the sections that are supposed to be on there. It's like supposed to be 17 pages or something like that, or the template is 17 pages. So it's a lot to go through. But I'll get that posted in the files section of Canvas as soon as I get it done. What you should be doing this semester. Attend class. Well, getting a good grade is virtually impossible if you do not attend class. If you must miss class, let me know and I'll work with you to keep you caught up. There's a variety of reasons we'll cover a little bit later that you might miss class for legitimate reasons, being sick, band, sports, whatever. But I'll be willing to work with you. Take notes. Taking notes helps you absorb the material. And as I've stated before, you'll be allowed to use those notes on quizzes and tests. Printed notes, no tablets or laptops. If you take notes on a tablet or laptop, print them out before the quiz or test, and you can use those. Ask questions. If you do not understand a concept, let me know. I will be happy to reword it, explain it a different way, help you understand it. My job description is to teach students, not stand up here and listen to myself talk. So that means if you don't get it, I'm not doing my job, and they will not keep me here. So let me know, and I'll rephrase things and try to get the ideas across. Important to take notes. Processing. When you take notes, whether you're typing on a laptop or handwriting in a notebook, whatever, you are translating the information from what I'm giving you into a more consolidated form. It's not like a video that you can watch and you record everything. It is something that you've processed to condense down onto a sheet of paper or on the keyboard of a laptop. So some processing of the information is being done as you are taking notes. That helps you absorb the material. What you do with those notes, that's up to you. If taking notes gets it into your head, and you can throw the notes in the garbage on the way out the door, that's up to you. Okay? But taking notes helps you process the information that's being presented. Organization. Organizing your notes so that they make sense to you. How you organize your notes and how your neighbor organizes their notes may be different. So don't rely on somebody else's notes that you don't know how they're organized. Take your own notes, organize them how they make sense to you, so you can refer to them quickly and easily during a quiz or test, and you can access the information more efficiently. And again, paper notes are allowed on tests and quizzes. Please print them out before the start of the quiz or test. Basically, that's my answer to how do you deal with ChatGPT in the class. Well, paper tests, paper notes, no computers involved. At most, you can have a calculator for doing some math, and there will be some math involved in this class. So, but no internet being used during quizzes or tests. What I will do this semester, allow notes, record the lectures, and be available. So I don't know if there's anything else that I can do to help you guys. If there is something more that I could do to help you in this endeavor, please let me know. I'm not perfect. I'm not the be-all, end-all of instructors. I know that there's room for improvement, but sometimes that improvement comes from suggestions from students. So, these are what I will do to help you along. I understand special circumstances. If you have a disability, sports, band, student organizations, travel to conferences, interviews, and you need to miss class for some reason, let me know. I'll work with you. Anybody here in the band? Ooh, quite a few. Okay. I know you travel to performances and that sort of thing, and will likely miss a class or two, or more maybe. That's fine. That's fine. I can. I record the lecture so you can catch up when you get a chance. In that way, I can. If you miss a test, I can give makeups. Without penalty. That sort of thing. Any athletes? Oh, got a couple. Again, travel to games, events, that sort of thing. That's I can accommodate that. I don't know if I've ever had anybody miss because of a student organization obligation, but I know student organizations, whether they're fraternities, sororities, or various clubs on campus, have events or might travel to conferences. I can work with that as well. That's part of college life, is those student organizations. Interviews. You got to go where the money is, and you pay to be here. Interviews are for getting paid. So, if you have an interview for an internship or a job, let me know, and I can work with you in keeping you up to date in your classes, or in this class, and gotta go where the money is, which is also sports and band. Some athletes and band members are on scholarship with those organizations, so you have to, they're paying the bills. You have to take care of those obligations as a priority. That's completely understandable. Travel to conferences, I highly recommend those. There are very educational opportunities. The chance to travel on other people's money. That sort of thing. Meet new people, network, possibly get internships or job offers at various conferences. So if you have the opportunity to travel to conferences, go ahead and take them. Don't worry about missing class. We can work around that. Most conferences don't last more than 3 or 4 days, so you shouldn't be missing too terribly much time in class. When I was an undergraduate, my first conference was a conference in Khartoum, Sudan, in Africa. So we were there for a little over a week. Very eye-opening experience, and I wish that type of experience on all of you. That get to see other parts of the country or the world and learn new things, see how other people live, how other cultures work, that sort of thing. Any questions for me about how I'm going to operate the class? Like I said, a good chunk of you have had me for Intro to ECE, so you kind of know what to expect from me. Uh, but those new. Any questions? Oh, one last. My office hours, official office hours, are Monday, Wednesday, Friday, noon to 2. I'm typically on campus before that. Most days I'm here by around 8:30. So anytime before noon, you can stop by my office, which I didn't put my office location on the slide. It's at room 237. Everybody know where Miss Seaton's desk is? In the department office suite upstairs. You know, my office is just to the right of her desk. The second door down. There's the department chair, and then my office. That's my email. Most folks generally reach me through Canvas, which is fine too. It gets routed to my email. And that is my personal cell phone number. Don't abuse it. If you need to reach me quickly, probably not calling is the best option, but texting is. Unrecognized numbers I often ignore as being probably spam or whatever. Telemarketers, that sort of thing. So text me that you're going to call me. Let me know who it is. I'll answer that number when you call. Yeah, but that's for emergencies only, really. But nobody's abused the privilege of having my cell phone number yet, but don't want to start now. But that's about it for the slide presentation. We can go ahead and a little. I've taught this class before, but it was a Monday, Wednesday, Friday format, only 1 hour apiece. This is 2 days a week, hour and a half each. So I might fumble around a little bit on the scheduling of when things are happening and that sort of thing. This is a let's see here. This is has an accompanying lab. I do not teach the lab. Honestly, I don't know who does. Generally, the rule of thumb is the first 2 weeks are just lecture and no lab, unless they are doing safety and lab protocols in the first couple of weeks. You have to check with your instructor on that, but the part of the lab that where you start putting things together, we don't cover that in class until in the lecture until second or third week. So you've got a little time before you start doing stuff in the lab. But anyway, we can start with a little bit of a lecture today. Not too terribly long. I'm probably not going to do the full hour and a half or hour and 20 minutes each day. I have a class in a different room, another part of the building, immediately after this. So I'll probably cut things a little short, a little early to make sure I can get everything taken down here and set up in the in my next class. So, and I generally use the whiteboard, not the smart screen. I will today because that's how I have the camera set up. But we are going to be starting with number systems. In particular, we're going to start with the decimal, which is base 10. We use base 10 largely because we have 10 fingers. It wasn't always this way. Societies have used different number systems through the years. Ancient Mesopotamians used a base 60, which had 60 symbols representing the 60 values of the base. That has actually survived in the form of 60 seconds to a minute, 60 minutes to an hour, that sort of thing. You count to 60 and then you roll over into the next column. We'll get into that more in a little bit. But that was the ancient Mesopotamians did that. Ancient Romans had Roman numerals, which you've probably seen, like the Super Bowl, the number is represented in Roman numerals. That's not an easy base to do, not an easy system to do math with. Roman numerals actually didn't have the number 0. The ancient Romans, to represent, instead of the number 0, they used the word nihil, which means nothing. So it's kind of a weird number system to use and cumbersome when it comes to math. The base 10 system comes from the Middle East. It's called the Arabic numeral system. 10 symbols. The base is the number of symbols, so we have the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the base of a number system is the number of symbols that are used to represent numbers. Okay? When you run out of symbols, like when you get to 9, you roll over back to 0 in that column and add a 1 to the next column. Simple counting. You were doing this in what, second grade? First grade? Something like that. But the digits represent, let me do this a little bit differently. The different digits in a multi-digit number represent how many powers of 10 of the different powers of 10 are included in the number. So a number such as this is going to be 7 times 10 to the power of 0, which is 1. So that's 7. 8 times 10 to the power of 1, which is 10. That would be 80. 4 times 10 to the power of 2, or 100. So 400. 3 times 10 to the power of 3, 1,000, or 3,000. Add those together, and then you add those together, and then you get your value of your number. Again, this is just a review of what you did in elementary school, just a little bit more technical. We can go to the right as well. You have the decimal point, or more properly, the radix point. So you would have, in this case, 8 times 10 to the negative 1, or 1/10, 8/10, and 2 times 10 to the negative 2, or 1/100th, 2/100ths of a whatever you're counting. Now, addition, math with different number systems. Math is kind of like counting, addition. So you have, say, 432 plus 439. You run out of symbols. 2 plus 9. You run out of symbols, so you roll over. So you go from 9, 1, 2, you get a 1. And then add a 1, like you're counting, add a 1 to the next column. And add those 3 together to get 7, and then 8. So you have this carry operation when you run out of symbols. Now, why I'm going over all this basic math, it will make itself clear when we get to other number systems. It all works the same way, it's just different symbols. Okay. Now, subtraction is just adding a negative number. So it's still addition. So you say you're going, let's see here, 423 minus 372. You're adding a negative 372 to 423. So you get a negative 1 here, or a 1 there. Now here, you run out of symbols. Your 2 is less than your 7, so you have to get more symbols. You roll over 2, then 1, and then you're at 0. You need more to subtract from, so you borrow 1 from here, make that 12, make that a 3. Then you could do 5 here, and then 0 here. So there's the concept of borrowing from the next column, just 1. You don't borrow any more than that. It's basically just addition with negative numbers. That'll be important when we get to binary. Multiplication is just repeated addition. So we're still working with addition here. So say 421 times 38. You multiply 8 times 1, 8. 8 times 2 is 16, which is 6, and roll over a 1. And then 32 plus 1 is 33. And then with your second digit and each subsequent digit, you shift that number of positions and do multiplication yet again. 3, 6, and 12. Okay, then you add them together. 8, 9, 9, 5, 1. That's called the shift and add method of multiplication. Now, theoretically, you could just do add 421 together 38 times, still addition. But the shift and add method is a little bit more efficient. Each line here is called a partial product. The partial products are calculated and then added together to get the final result. When we get to hardware multipliers, we'll see how that works in circuitry. Division is just repeated subtraction. And there is a way to do a shift and subtract process in for division. But you can simply just repeatedly subtract the divisor? Yeah, divisor from the dividend. Is that right? Yeah. Or is it backwards? Anyway, you could repeatedly subtract the second number from the first number, and however many times that you can subtract it, that's your quotient. But there is a shift and subtract method that resembles the multiplication process of shifting and adding. That's not covered in that process is not covered in this class. I believe it is covered in computer architecture, how it's done and how you get your quotient in that process. But anybody have a problem with base 10? Been using it most of your life? Yeah, it's pretty basic, but look for these common themes. The base is the number of the power of the digits, and it is the number of symbols that are used in that system. Now, to get into how computers see numbers, when you type in a number, it is assumed to be decimal if you're just typing in the number. on paper, on quizzes and such, to designate the fact that the number that you're given is in decimal, you would put a subscript of 10 or a subscript for the base that you're using. So when we get into binary, you would put a subscript of 2 to indicate that the number is binary. Or hexadecimal, which is base 16, put a subscript of 16 to indicate that that's the base that you're representing. Let's see here. Computers do not use base 10. They used to, internally, that is. Early computers, mechanical computers, used base 10 in their calculations with the gears and all that sort of stuff. When digital electronic computers came around, they shifted to the use of binary, which we will cover on Thursday. But again, remember these core principles. They are the same in various number systems. You're just changing the base. Okay? So, honestly, that's about all I got for you today. Just remember the base, the subscript, and it might come up that this is a radix point. To indicate fractions. So keep those things in mind, and we will cover binary in excruciating detail on Thursday. Have a wonderful day.